Hi there. Thank you so much for coming to the meetup. I'm Sandy with Elasticsearch. It's great to see so many familiar faces that I've seen in previous ones. We've got an amazing group of people here to talk about what they're using. Garrett's going to introduce the Atlassian team, HipChat, which Elasticsearch uses internally. Great tool. And then Zuhaib's going to be talking about how they are using it. And then we've got a lightning round coming up with Robert from Quizlet. Very interesting use case of how they're using Elasticsearch. And then Shai Bannon is here, so he is in the back there. And so Shai, who's the creator of Elasticsearch, happens to be in town this week. So he's stopped by, and he'd be happy to do a little bit of a short Q&A. He's a little jet lagged, having just flown in from Amsterdam, but he'll be glad to answer a couple questions towards the end. So anyways, Garrett.
Hey everybody, I'm Garrett. I'm one of the co-founders of HipChat, and welcome to Atlassian. For those of you that don't know, Atlassian is the company that makes Jira and Confluence, which are the world's biggest or most widely used issue tracker and internal wiki. The name is often not associated with those products. So anyway, we make a lot of tools that you probably use, and we're big fans of Elasticsearch. We've been doing a lot of stuff with it lately, and Zuhaib is going to dive into the nitty-gritty of the crazy things that we're working on. So here he goes.
Switch. Hello. Anyone can hear me? So as Garrett mentioned, my name is Zuhaib. I'm with the HipChat team. Been with them for over a year and a half now. Came previously from a small startup called Auction Cloud, and I'll be talking today about heavy lifting and how I have so much feedback. Can you guys hear me now?
Yep.
Cool. And we'll be talking about heavy lifting and how we use Elasticsearch here at the HipChat team to let us scale to over 1 billion messages. So, these are the wrong slides. Wah, wah, wah. Never mind. That's what happens when you have last-minute edits. Bear with me, please. Credit goes to Pete, one of the co-founders of HipChat, that helped me perfect these slides. So I noticed that those were my designs, so it couldn't be right. So what is HipChat? Well, HipChat's group chat and IM built for teams. So how many people here have used HipChat? Whoa. Okay. So the next couple of slides might be entirely redundant, but we'll go over them anyways. So what makes HipChat unique? First and foremost, persistent chat rooms. So other chat products like, I don't know, like if you use AOL back in the days, or even Skype, they have a hard time doing persistent chat rooms. HipChat's built all around the concept of persistent rooms. You create a room, it keeps the chat history. It has the people who are a member of the room. You can even have it set private, so you can do access control, who can join the room, who can leave. File sharing and chat history. So chat history is a big one for us and why I'm up here talking today. We store all the chat history. You can index it from when your company joined. We have some teams that have been with HipChat since 2010. We still have all their data if they're active. And also file sharing, so you can do attachments and links, PDF, and also preview. At mentions and notifications. So one of the nice things about HipChat is you can do mention people. So in this example here, we're doing at all. And it will then be sent, if someone's offline, it'll go to their email client. If they have our mobile apps, it'll be pushed to their mobile apps, iOS and Android. We have native apps on both of those as well. And integrations API. So if you're a developer, you probably are really familiar with this stuff. We integrate with Bitbucket, Bamboo, Jira. We allow you to push notifications to the room, so you don't have to create a user for like an XMPP bot or an IRC bot if you're familiar with that. You just have a service user API. In this case, someone's doing some developing. And the really big one, we run on everything. And what does it mean by everything? Well, Windows, Linux, Mac, native on all three. That's something we recently made a big push for. Also, as I mentioned earlier, on mobile devices, iOS, Android. And if you refuse to install our client, you can use it on any web browser. I think Shay mentioned that the guys that he uses in the web browser client. So as I mentioned earlier, it's group chat and IM. Here at Atlassian, we're big, we love HipChat. I mean, it's the reason why they acquired it. But it's more than just that. It's more than just Atlassian. It's all these great companies also that use HipChat, including Elasticsearch themselves. So with so many great customers on HipChat, there's going to be a lot of chatting going on, a lot of messages sent everywhere back and forth. So we recently blogged that we hit 1 billion messages. And it's a big milestone for us. Well, at least for us it is. And we hope for you as well. But it's more than just 1 billion messages now. Actually, since that announcement, we're now at 1.2 billion messages. We're trending to hit 2 billion messages probably within a year. It took us 2010 to about 2013 to hit 1 billion messages. We think the next 2 billion will be well short of that. And the next couple billions, maybe a few weeks, months, we don't know. So what does a HipChat message look like? It's this, basic JSON doc. If you're familiar with HipChat, as most of you guys mentioned, you know we use XMPP, but we don't store in XML, we actually store in JSON. There's a reason for this madness, I'll explain later. And all your basic metadata from, room, and your body, in this case, Elasticsearch for the win. There's other stuff as well, but we don't need to go into that for this talk. So in the beginning, there was CouchDB. So where can we store a JSON doc? The most logical place for us was CouchDB. If you're not familiar with the project, it's a JSON document store. You throw your JSON doc on it. You can do map reduction views and all that sweet stuff. But it lacks one key feature, search. And as I mentioned, chat history is huge to HipChat. So we layer on top of that CouchDB Lucene. It's an open source project, I think. Yeah. It's their official logo, I kid you not. When we found this, at the time, we were having a lot of issues with CouchDB. We kind of imagined the guy got drunk and is falling on the floor. I'll get into that more later as we progress in the talk, and it makes more sense. So in the beginning, we just had, when HipChat launched, we wanted a simple architecture. You don't want anything complicated. You wanted that new buzzword, minimal viable product. So we combined CouchDB and Couch Lucene on a single Amazon instance. If you guys haven't seen our previous blog posts, we're fully committed to Amazon. We run all of HipChat there. So we had a nice M2 4XL. It was great for about the first 200 million docs. Then, started seeing scaling issues, so we took the most logical step. We split up the two, put a Redis cache in front of CouchDB. So now the 75 messages sent are first cached in Redis. So when you're loading your room, we buffer that. It's a great way of preventing CouchDB from being overwhelmed. And we gave CouchDB its own little instance. Was all happy. Everything was happy for the first 500 million messages. Then, drunk dude falling off couch came back. CouchDB, our index started growing really large. We began, consistently, we went to the second largest instance on Amazon at the time, which is an HS1 extra large. It's something like, I don't remember how many gigabytes of RAM it was. It was a lot. CouchDB and Redis were actually pretty happy in their own little verse. No, we had no scaling concerns at that point, but CouchDB Lucene was pretty much tipping over. As I mentioned, still wasn't even big enough at that size. We were, as Atlassian's saying, is don't blank the customers. If you guys happen to take a look at the banners over here, Atlassian has this kind of motto of one of them is don't blank the customers. We want to make as little friction as possible. Well, our search was not doing that. We were receiving daily tweets of our search being down, our help desk with people complaining. Even myself wanted to, we have a little board in the office that shows all the top tweets with the word HipChat mentioned. I wanted to throw something on the board because everybody was complaining. Search was broken. So our first attempt at scaling, we knew evidently that we weren't getting there. We needed more power. So we kicked off a search to see what other data stores, what other search engines are there around besides CouchDB Lucene. That landed us on Elasticsearch. So why Elasticsearch for HipChat? A couple reasons. I'll be getting in those in a little bit. The first, the fact that it's horizontally scalable. So if you're familiar with the Elasticsearch architecture, one of the great things about it is you can just add a node to Elasticsearch and to your cluster, and it'll just grow horizontally. More nodes for more indexing power. You can distribute your shards across. A lot of products promise that. Apache Solar, I think, recently announced they're going to be doing some sort of clustering stuff. At the time when we looked at it, they weren't. And it was really hard to find a really good clustering solution for search. A lot of things you can throw more power at it. I think React is a little bit doing it, but I haven't seen many good results from other customers. But Elasticsearch truly, from our testing, you can throw a node at the issue, and you can lose a node, and the cluster will rebalance. It's something really important to us, especially being living on the Amazon verse. Living in Amazon, that'd be kind of interesting. You can have a node go away at any given time. So we have to be prepared for that failure mode. Another thing, the fact, as I mentioned, we use CouchDB Lucene because it was crashing every day. We didn't want to rewrite all of our search code. So we needed something with Lucene support. And one of the things Elasticsearch has is support for Lucene queries. So it allowed us to quickly get Elasticsearch cluster up, import our data, which was a little interesting on itself, and quickly get Elasticsearch into our production stack fast. Next is the fact that Elasticsearch is open source. So we looked at other cloud providers like Cloud Search, Cloudint, and they all look great, but you can't ship them behind the firewall. Recently at Atlassian Summit, we announced that we're bringing HipChat server, allow you to deploy HipChat behind the firewall. Well, we needed to have a product we can ship, and Elasticsearch allows us to do that. Also, we find it works pretty well even on VMs. So what did it do for us? Well, as I mentioned earlier, we were, Couch Lucene, we were pretty much screwing the customers consistently. When we switched over to Elasticsearch, we saw our average error rate drop from about 1 to 2% with a spike of 7%. This graph captured it perfectly, to almost 0% with a couple spikes caused by us doing maintenance that we probably should not have been doing in the middle of the search hours. And so we thought, hey, success. The search is solved. We can now all kick back and relax. Not exactly. This started to happen to us. Don't forget about CouchDB. Our CouchDB data space, the data it needed to store on its EBS volume started to grow. Couch, if you're not familiar with it, has this concept of compacting. So it takes your data, copies it to make an optimized B tree, and then deletes the previous data away. But for that short time, you need about almost roughly double the space. And we started to see a march towards the 1 terabyte limit. As this graph shows, we actually passed it. I'll get into how we were able to do that. And it ended up hitting the 1 terabyte limit not too long ago. This is from September. And it causes a lot of pain. So to stop the bleeding, we threw in EBS RAID. If you're not familiar with that, the ops code guys have a great cookbook called AWS that you can automate standing up a RAID. We now have an 8-disk, 4 terabyte RAID, something we don't really want, because we also have to have this on our main node and also our slave. So CouchDB was at the end of the road. It was burning on fire. And so we were looking like, well, what can we do to get off of this? Then suddenly we had an epiphany. Why don't we switch all the things to Elasticsearch? You might be asking, well, how can we do that? Elasticsearch is a search engine. It's not a key value store. Well, actually it is. This is a comparison of a CouchDB doc, the same document I showed earlier, an Elasticsearch version. And here's a little highlighted. Doesn't like me here. You can see, hopefully those of you in the back, on the red part, that Elasticsearch stores the exact same document CouchDB does. It has the body, the room, and the from in the source field. On top of that, you already have an index as well for the search. So we're like, well, if we can remove one more component from our architecture, meaning CouchDB or anything else, React or Big Couch, this would be a great win for us. We understand Elasticsearch at this point, or we think we do. So what does it result in? What does it turn out when you roll it out? Well, this. As an experiment, we switched our website to use Elasticsearch for all of its loading of chat history, like I mentioned earlier. We had CouchDB returning results for the website at about 200 millisecond average, with spikes up to 800 milliseconds, down to 100 milliseconds with Elasticsearch. That was a great win for us. Faster website response, customers are more happy. It's a great thing. No more screwing the customer. So how do we run Elasticsearch shared HipChat? Well, lots of nodes. So we have 3 dedicated master nodes and 9 dedicated client nodes. You might be asking, why do we have dedicated master nodes? Actually, I have to give credit to the fellow tool over at Loggly. They hosted a meetup just like this, actually, and they were talking about their architecture. And we brought up the fact that we were seeing daily brain splits on our Elasticsearch cluster on Amazon almost every other week. They said they had the same exact problem on Amazon, and they solved it by switching to master-only nodes. So that way they dedicate only for master election, don't have to deal with that, don't have to deal with handling the clusters and everything else, handling data. So we now have 3 master nodes, 9 clients across 3 Amazon availability zones. That gives us failover in the event that an entire zone goes down, your searches and data results will still be returned. To manage all these nodes, we use opscode Chef. So the great thing with Elasticsearch, guys, if you're not familiar, they have an open source Chef cookbook. We use that, and just so happens that the opscode Chef guys are HipChat customers as well. So how do we set up a new node? Pretty simple. That's it. Any developer can go to any one of our ops boxes, and we have ops job boxes, and type that in, and you'll end up with an Elasticsearch node. A lot goes on behind the scene, and we're using Fabric to kind of abstract a lot of that. So first, it spins up an EC2 instance using the knife command. Knife is a kind of a command line API for ops code chat. Installs Oracle Java 7. Creates a provision IOPS EBS drive. This is great. The Elasticsearch cookbook guys have that all coded up for you, so you don't have to fiddle with the Amazon UI and try to configure the CLI. It all's done for you. Just provide it with a key. Installs and configures Elasticsearch. So it configures your Elasticsearch node for you, be it a client or master node. You define that at the deployment time. And then you get to sit back and profit. Except there's one little step in that you need to let your clients know how to talk to Elasticsearch nodes. So we actually have Chef do that for us as well. It searches out all of our Elasticsearch servers and generates a simple JSON doc, which we call site.json, that encapsulate all of our Elasticsearch nodes. Our clients read that file. It updates every 30 minutes. The clients, the applications know if the file has been updated or reload. That way, we don't even have to touch that. So we can scale our node, we can scale our cluster dynamically, add nodes, remove nodes, and still go on. All the while, you can now be the red guy on the couch and relax. You don't have to do anything. So, I love this slide. So Java. The HipChat guys, we are primarily PHP, Python, with a little bit of Ruby. Java, we've all managed a Java server once in our life. Maybe you've done it in college. I did it in college. But it's not the most sexiest application. Actually, Atlassian's a Java house, so I shouldn't slam on it too much. But it was definitely something new to us. So a couple of caveats kind of caught us with surprise with Elasticsearch in production that I'd like to talk about quickly. First is monitor your heap space. If you don't do that, this will happen to you. We had a single node that, for no apparent reason, wanted to use more heap than everyone else. Actually, we had a couple nodes that just thought they were special. We rolled out the new web feature and thought, like, hey, success. The website loads faster. We got that beautiful, sexy graph, and we all headed out to coffee. Actually, a sight glass down the street. Unbeknownst to us, it OOM'd, and we only got alerted when the cluster tipped over. So some of our customers got timeouts when they tried to connect into this bad node in an OOM state. And then, as you can see, the node cluster tries recovering. It does recover eventually, which is great. One of the powers of Elasticsearch, you can lose a node, and after the recovery time, it kind of comes back, and everyone's happy. But one of the things we can not emphasize important if you're going to do Elasticsearch, which I think a lot of you guys are probably thinking about or have already done, monitor your heap space. I know it sounds simple. We probably should have been doing it, but it kind of slipped us. So we actually use a product called Sensu. How many people here use Sensu, actually? Ooh. OK, besides the HipChat guys, I saw one hand. We use Sensu for monitoring. It's a love-hate relationship. I love it. Everyone else hates it. We wrote, actually, we kind of hacked one of their Elasticsearch plugins. They have a lot of great plugins. All the graphs you saw were actually compilated using Sensu to grab those data from, not all, but most of them, grabbing cluster state and how much heap memory is being used. And we now use it to monitor our heap memory. It actually had a little plugin to do that with finite values. We added percentage support, and I should be pushing that out some point soon. Another thing I was talking to with Shai is backups. With Elasticsearch, you hear a lot of people come and talk about, well, how do I do backups with Elasticsearch? Right now, the current version doesn't have a real backup support. So we actually found that using EC2 EBS snapshots, consistent snapshot with XFS file system, works really, really well. We actually rebuilt our cluster in our dev environment a couple times from production data to confirm that, and we were very happy the fact that we were able to get all of our data back consistently. So definitely don't even think about rolling Elasticsearch out to production without some sort of backup. And if you're on Amazon, use EBS snapshots till they release 1.0, which hopefully Shay will answer during our Q&A when 1.0 is being released. So what about the 100 billion question? As I mentioned, we're growing at a really fast rate. Elasticsearch is not a silver, it's not a magic bullet. It's not going to solve all of our scaling problems. We have a lot coming up ahead. We're actually hoping some of you guys might be interested in helping join the HipChat team, help us solve that problem. If you are, look for someone with a HipChat shirt on. They'll help you get you in touch with the right people. But we think Elasticsearch, the architecture of horizontal scaling out and the fact that it really does work will get us a far away. And that concludes my talk. any questions, just please wait for the mic. We're recording this talk as well.
Just really quickly.
Oh, I'm sorry. I think I have you muted. Go try again.
When you talk about your heap space problem related to Elasticsearch, was that a Java issue?
We couldn't.
Does it run on JVM?
It doesn't run on JVM. That one node running away, we really couldn't troubleshoot what was going on with it. Like I mentioned, we're not super. We weren't seeing the traditional slow garbage collection on it. It was just running away with heap space, and so we ended up just killing. And one of the nice about Amazon, we just killed the node and spun up a new one, and suddenly the new one didn't exhibit the same problem.
So what do you do now when you monitor it and your heap starts to get out of control? You just kill it? And
No, if it starts going out of control, we're looking at what we've done to the cluster. In our case, when we saw that spike, we disabled caching. We were using the field caches, and we didn't need it actually for the performance. That graph I showed is with field cache disabled, and it's worked great for us. We disabled that so we use less cache memory. But if it's something that's going out of control, we might spend some more time next time, but we haven't seen this since.
Thank you.
No problem. Any other questions?
Can you talk about little more about the index size at HipChat and how do you run on AWS for the node, for the data node and for the Masternodes?
Sure. Index size is in how much document space we're using up right now. It's actually kind of hard with Elasticsearch because it's across the 9 nodes. I haven't taken and we have about double replication. So I know it's below the 75% threshold because it would alert me if any of our Elasticsearch nodes were over that. With somebody knows it's kind of hard, so I can't comment on the exact data size. We also, we use best practice. We have compression enabled, and as I mentioned, we have double our replicas. That also helps us prevent in a data loss scenario. What else? Amazon related?
Yes, split running.
Or
What instances do you run on Amazon?
what instance size?
Yeah.
Oh, off the top of my head, I believe it's M3 2 extra large, right, Matt? Possibly. I know it's one of the new generation instance sizes. They supported Amazon touts much more better CPU with those. Also, they support provision IOPS. So we also use, as I mentioned in the talk, we use provision IOPS for Elasticsearch to kind of get around the whole EBS performance problem.
Hey, good question. How are you doing the snapshots? Are you synchronizing them somehow? How do you keep that consistent?
Old school cron. When we deploy the box, we configure a time to run our cron jobs across all of them. And obviously we keep them in NTP sync and we fire a unison EBS snapshot call across all of them, or cron handles that.
Okay. When you hit the split rank before going to the 3 dedicated master nodes, were you running the nodes all in the same region?
No, they were across all of, single region, yes, all in US East, but across different availability zones. I think there's a question up here.
Have you guys thought about using solid state disks?
We haven't thought about using solid state disk yet. We're not seeing a lot of I/O problems with Elasticsearch. It's just hasn't been a problem for us right now. There's one more question in the back.
Hey man, how did you go about moving from CouchDB to Elasticsearch as a data store rather than a search?
So the process actually, as I mentioned, was pretty seamless because when we ingested their data into Elasticsearch, it automatically stores your source field, the entire document. So the transition over for us has been pretty much just rewriting our code to use Elasticsearch as a data store, to use it for getting gets, and still using the same, as I should have glossed over that, we still use the same Redis cache to buffer Elasticsearch. So the initial 75 messages for the first 2 weeks are stored in our Redis cache and expired after 2 weeks, or 75 messages are being chatted. So that also prevents, most of the time people are in an active room, they're talking what's going on right there, so you're always getting from the Redis cache. And then if someone does a long history request or starts, hasn't been in the room for a while, then we have to pull Elasticsearch or CouchDB. Getting from CouchDB to Elasticsearch could be a talk on its own. The Elasticsearch team, we had some consultancy hours with them. They gave us a lot of assistance in how to write a custom Ruby app to actually migrate the data over. The CouchDB river is not suitable. Do not use that river at all. If you're a CouchDB user looking for Elasticsearch, do not look at the CouchDB river. Actually, I should have mentioned that as a big slide. Just don't. It's not ready. Well, it's not good enough. Just write your own importer. Any other questions? Oh.
How long did your process take to move from CouchDB to?
I wasn't going to, hoping no one's asked that one. It took us a while. With all of our false starts, we started looking at Elasticsearch, I believe, around the same time last year, November. Getting the data ingested in there, actually migrating the actual data across, took about a couple weeks to get over about, at that time, just over 500 million messages when we started. Then by the time we caught up, we started writing directly to Elasticsearch. But it took about almost a week getting our importer script. And then the process of getting it, also, it doesn't help switching over to a new product if the person leading it tears their ACL, which happened to me. So that not a great way if you want to re-architect your system to destroy your knee. So also, again, another Elasticsearch tip, don't ski if you're cutting over. Oh.
How do you deal with Elasticsearch version upgrades?
Did I mention that they do really well failover? Pretty much right now we will choose a quiet time and slowly roll over each node, kind of fail over on it and allow Elasticsearch to kind of handle that right now. So right now we just pretty much upgrade a single node, let it come back online. The node cluster state will go yellow, but luckily with Elasticsearch it will rebalance and still handle the request. And then we'll just kind of roll over each node manually. We would love to see a more automated process for that. I'm thinking about writing a script that kind of automates it, but right now we just kind of do it manually. I think that should be it. We'll still be around, the HipChat guys, so if you have any other questions after the talk, just find someone in a HipChat shirt.